Hello, everyone. Let's get started, shall we? I want you to go back to a time when you used to work on a project that you really liked. You really enjoyed working on it. Be it a passion project or something at work that really made you, happy, right? You really enjoyed working on it. Deploying, new features, bug fixes, whatever it may be. Now, remember if you've had any kind of these projects, passion projects that became really frustrating when it came to building, right? It started off as a really tiny, 200 file thing. It built in 5 minutes, and then it kept adding more and more features, more tech debt, fewer bug fixes. It takes an hour to build, and how that just ruined your day. Whenever you just want to get in like a one-line fix, it takes you 30+ minutes, an hour, 2 weeks or so, assuming you get past flaky tests. I'm sure we've all had those kind of moments. Okay, now think of it this way. The frustration, all of those, feelings behind it. You think to yourself every day, there has to be a better way, right? This can't just be it. Just building the same thing over and over and seeing how it takes longer and longer. There has to be something simpler, faster, more scalable. And I'm going to talk about that today. There is such a thing. Imagine a system and a process that can take your passion project that used to take, 5 minutes to build, it became an hour, and then back to 5 minutes through this system. That is what we're going to talk about today. Hello, everyone. My name is Andrei Timofticiuc. Everyone calls me Timo. I encourage you to do the same. I'm a staff software engineer at Google and the current tech lead for iOS at Fitbit. Based off of the awesome Bucharest office in Romania, obviously, we have everything you could ever possibly want. Engineers, product, design, testing, you name it, we have it. From this location, we have led and landed successfully in production huge projects that span across multiple teams, across multiple product areas. So with that in mind, let's talk about the agenda. What are we going to talk about today specifically? 1, the challenge. What is one of the projects that we worked out of the Google office in Bucharest, which had an immense impact across all of the engineers, everyone contributing to it from a non-engineering standpoint, and all of our customers? We're going to specifically talk about how we migrated 2 very large mobile code bases, respectively the Fitbit iOS and the Fitbit Android code bases, from our legacy, not legacy, but old school infrastructure, 100% to Google's infrastructure. 2, the solution. What enabled us to do this in safely moving everything from one part to another without causing any production incidents, right? Mind you, this is a project we had to do without disrupting developer workflows, feature rollouts. There ties in with devices. So for those of you that have worked with factory devices, once you get in a device at a factory, that's a contract, that's a schedule, you can work around it. Now imagine you have software tied to that device. So it gets really tricky really fast. And finally, the results. What do we have to show for it after this entire period of migrating these code bases? Spoiler alert, nothing. 0 incidents. But we'll get to that. So, the challenge. As previously stated, how do we safely migrate our build infrastructure without users noticing? Now, when you think of users, especially mobile users, and build infrastructure, you don't really see the parallel between them. Why would everyday users of a mobile app care about build infrastructure? It means nothing to them. That's the catch. The way you build, right? So the way you compile, the way you link, and the way you automate everything basically dictates how your app is going to behave. Let's say there's a tiny optimization flag that you pass to a very specific module. Okay, so that works to strip out some dead code. Now, imagine you miss that flag specifically in a new infrastructure. That is going to lead to runtime issues and basically customers complaining about your product. So, very careful about it. This was the first time something like this was attempted in 10+ years. We got this confirmation from one of Google's internal teams that dealt with acquisitions. So everybody was very surprised when we told them, OK, we want to get these two code bases from our infrastructure over into yours. How do we go about that? Well, figure it out. There's a lot of internal processes you have to go to, but it was mostly a learn-as-you-do experience. These code bases are 10+ years old. So the initial source files were written sometime in 2010, something like that. So you can imagine there's a big bunch of, old Java, new Kotlin. On iOS, we had a lot of Objective-C, some new Swift, a lot of C++, a lot of bridging headers. So there were a lot of things that we had to take into consideration and making sure that once we move them, everything behaves the same. On top of that, all of our tooling was custom, right? Because the standard developer workflow was Bitbucket, obviously, Jenkins, double obviously, and over 200 Python scripts. Triple obviously, because why would any engineer be happy with what they get? No, we have to rebuild everything from scratch. And that was a bit of an issue. OK, we'll migrate the code base, sure, but all of this custom tooling written over the span of 10+ years by people that moved on to different companies, and it's a lot of historical data that you don't have access to anymore. So that was a clear unknown for us. We tackled this from 3 perspectives. Number 1 being at the top, the mobile application. That is what the user sees. That's our bread and butter, right? As far as they're concerned, nothing needs to change. They need to receive the same binary as if nothing has happened. OK, cool. How exactly are we going to do that? Well, we move one level down into IC, ICD, and developer productivity. Now, that is the layer that directly impacts the company itself. It impacts the developers that work on the projects. It impacts our testing through our distribution channels. We essentially had to migrate those as well. OK, there's one way of building and outputting a binary, having it signed, and then distributing it internally. We need to do it in a completely 180 different way now. The concepts are the same, but the tools are entirely different. And at the lowest level, where all these changes actually happened, we have dependency management, the actual build system, and testing. Super heavy emphasis on testing, since that was our first line of defense against issues, right? It was not enough for us to migrate the actual source files that go into the binary. We had to migrate over tens of thousands of unit tests, integration tests, UI tests. So more infrastructure, more migration. But it all paid off in the end. Whenever we had an issue that was not caught at compile time, but it was a runtime issue, we had this entire salvo of tests that would just start failing. And we could compare the results like, OK, it's working fine in the old infrastructure, but it's failing in the new one. Obviously, there's a problem with migrating a specific module. So for those of you obviously familiar with software engineering and product management, herding cats should be, something familiar for all of you, something that you've dealt with. How we dealt it, in our case, again, 3 acts. We love the number 3. It's all over in our projects, in our code base. So we split it up into 3 equal areas, namely build. This essentially meant migrating everything. All source files, all configuration files, all tools, and all scripts from the old infrastructure to new one. And just make sure we can compile, right? Just get a binary out. If we get it out, if everything compiles, that's great. We succeeded. The run phase. Now that we have a binary, well, let's get it signed and distributed internally. OK, but first, before we do that, we have to make sure that the thing actually runs. So we have our app. We put it on a phone. We launch it. It crashes. And so begins the process of fixing, I think, over 300 runtime bugs, which specifically goes back to what I said initially about missing flags. We had a lot of missing assets. Some screens wouldn't load a specific image, and that would cause a crash, and so on and so forth. So all of these tiny things we had to account for through automated tests, manual tests, and essentially just using the app. It got to the point where we encouraged people to install the new migrated version of the app, even though it was just failing. It was crashing all over the place. The first 2 weeks were essentially bug hell. But it was great. we made progress. With every passing day, we got 20 more bugs, we fixed a couple of them, and so on and so forth, till we had no more bugs, hopefully. And the last phase, release, that was the most important one. That's where the tire meets the road, right? Okay, we've done all of our automated testing, everything is compiling, everything is running. So far, so good. There's at least a couple hundred people in the company that are using the app internally and, haven't had any bugs in 2 weeks. So what's our confidence level? 99.999%, sure, cool. Now let's integrate with the Play Store and Apple Store APIs, which is essentially us finally moving and shifting away from our old Jenkins infrastructure, which handled all of this, building, releasing, and uploading. That was another migration in and of itself, migration to new tooling, which, sure, still Python scripts, except we don't own them anymore. It's a very specific set of scripts owned by the release engineering team, and you just have to adapt to them. So all of this work, all these things, testing, building, compiling, arguing over emails, in total, we counted about 150 plus engineers, because we just lost count at one point, spanned across over 20 teams in the company. Essentially, if you were touching the Fitbit product, congratulations, you contributed to this migration project, whether you liked it or not, as a PM, as a designer, and especially as an engineer. It was everyone's responsibility to migrate whatever they owned and adapt to the new infrastructure, because this is the future, people. Post-acquisition, this is what we're going to be doing for our day-to-day activities. And as previously mentioned, all of this had to be done without disrupting feature development and all of our releases. So there were essentially almost like two companies running in parallel. The regular one, which developed the features and did the releases and used the old infrastructure day-to-day, everything worked, that's great, no crashes. And our ragtag team of engineers that slowly but surely migrated day by day, percentage by percentage, making sure we didn't break anything for the other half. Because, again, we had to do this in incremental pieces. We couldn't have done it in just over a weekend or convince everyone in leadership to say, okay, let's just not do anything for a couple of months so everyone works on this. That's unacceptable. You're a product. You need to deliver once every 2 weeks. That is our release timeline. So we had a good number of people from product and other teams that were not that unfamiliar with the project itself, but didn't quite understand the scope of it. Why is it taking so long, and why is it so complicated? This is a metaphor we used to throw out a lot. So imagine you're driving your dad's car, and you want to go to the seaside. What we were doing was changing your tires, transmission, engine, windscreen wipers, whatever you want, without you noticing. That was the nature of this project, right? So the app is the car, the driver is the customer. Everything got changed under the hood, no one noticed a thing. That was a measure of success. Lack of incidents. So after going through this entire challenge, all these things we need to do, it sounds a bit daunting. So what was the solution? What was the huge, amazing process and system that we developed or found or acquired or whatever that actually helped us in this endeavor? Introducing Bazel. So Bazel is Google's open source variant for their internal build system called Blaze. So, Bazel, Blaze, I'd argue that as engineers, we're still not good at puns. We need to work on that. In any case, its motto is fast, correct, choose two, which is actually very correct as long as you use it correctly, right? A lot of correct going around here. Bazel works very, very well as long as you feed it the right information. And we're going to get to that on how it works. But this is essentially what we used to get from point A, our build infrastructure that was in the Fitbit stack, over into Google's ones. So, best parts about it. Standardized development. I cannot stress this enough, how important it was for both the iOS and the Android departments working together on this. Because essentially what happened was like a common denominator across how you build apps. It doesn't matter if it's Objective-C or Swift or Kotlin or C++ or Java. You're going to write the same type of rule for everything. How that works is with something called build files. For those of you familiar with make files or Gradle scripts, it's very similar to that concept. You define a library, you give it a name, my awesome library, you tell it which source files to include, and what does it depend on? Other libraries. And that's it. And you do that over and over and over and over again for as long as it takes till everything bundles together into one binary. Now, the best part about it is there's an actual dedicated community behind it. I know that gets thrown a lot in open source project, yes, community, responsiveness, yada, yada, yada. Okay, this one's actually for real. When we had a feature request, specifically for the Android rules, in about a week, the entire thing was done. There was a difference between how Bazel would build a specific rule and how Blaze internally would build it. That became a blocker for the Android migration. In a week or so, the Blaze rule was updated to match the one internally, and that was it, in and out. And we didn't use any internal processes at Google. This was us reaching out to the GitHub page, like, hey, we'd like to make this change. Thank you very much. Super responsive. So in the part about efficiency, it encourages engineers to think in bite-sized pieces. That's where the strength lies, right? If you have as many possible libraries, as many libraries as possible, like really small increments, that's where Blaze becomes super powerful, right? By default, it is a distributed build system, so that means it'll try to build in parallel as much as possible as long as you let it to do that by defining the dependency graph. So if you're going to have a project that has maybe 1,000 source files and you write only one build file for it that contains everything, well, congratulations. Sure, it's migrated, but is it better? No, you're still doing the same thing. How this works is you break everything into smaller incremental targets, right? Individual libraries that depend upon one another, and that creates the dependency graph, which then Bazel analyzes and understands like, okay, here's a set of targets that don't depend on each other. I can start building those in parallel, and then it goes up the tree, up until the final target that depends on everything, so you get your final app. It's insanely fast if you write it correctly. On top of that, there is a thingy called remote cache. We discovered this early on in the migration process, and it was a game changer. Essentially, it would mean that if I migrated a module and pushed that change into our Git repo, tomorrow, when you pull out the latest version of the repo, check out master, and build that same target, you don't have to build it from scratch, because the remote artifacts for that target are already updated, uploaded in a bucket, right? We had custom Jenkins job written specifically to build the master branch once every couple of 10 minutes or so, and that would always upload the artifacts of all the targets. This was super, super fast. Alrighty. Now, for both platforms, what it meant is that we replaced both of our build systems, Xcode and Gradle for Android, with Bazel. Hello. Okay. How we did this? Well, first of all, we started with the developers, right? The boots on the ground, the people doing the work. We wrote some small scripts that wrapped around Bazel, and essentially, okay, run this, it'll build the entire thing or your very specific target. But not much wrapping around it. It was still going straight through Bazel. We encouraged people to do this. Our team started migrating from the bottom up, different frameworks, different modules, and it became a process of leading by example. Other engineers would see this, and they'd be interested, like, okay, how can I help? How can I migrate my own thing? And this started disseminating the knowledge. On top of that, we introduced build jobs on Bitbucket. So whenever you would put up a pull request, you'd get assaulted by 3 or 4 build jobs that would build your project using the legacy system, which took north of 60 minutes, last I remember. In parallel, we would also run the same thing, but with Bazel. So this way, we ensured that whatever got migrated stayed migrated, right? So let's say I migrate target A today. You're going to modify it tomorrow. you have to update it to work with Bazel as well. Otherwise, your change is not going to go in. And we did this for everything, compiling all the source files, pulling in all the assets, and then running the actual unit tests for it. By the end of the migration, our legacy build jobs took about 60, 65 minutes for both platforms, which meant compiling, running tests, making sure they're not flaky, whereas the Bazel one took about 15 to 10 minutes in building and running everything. It became awkward when other engineers started asking us, like, hey, can we just disable the old build job because it's taking too long and I want to get my change in before the day ends? And like, sorry, no, we're only going to do that once we're fully migrated. So that was, again, a measure of success from our point of view. What makes it awesome? So if it's not obvious by now, it rebuilds only what is necessary. If you make small incremental changes in very specific targeted areas, then those places and the targets that depend on them are the ones that are going to get built. Makes sense, right? I can't believe we've gotten to this point in the IT industry where these issues still spawn everywhere. Especially for iOS, I feel like the build system has become more and more clogged up, where everything ends up depending on everything else, and there's no clear dependency tree. Support for major languages. Honestly, I have not seen a language that is unsupported for Bazel. Probably if you created your own syntax for a very specific version of TypeScript or whatever in your basement, yeah. But most of everything that's used in production is supported. And direct integration with major IDEs. So if you use IntelliJ, Xcode, Android Studio, doesn't matter, it'll work straight from it. You can use command line, but if you're like me and prefer the IDE, you like pretty buttons and all that stuff, it works straight from that as well. And it's a great tool that works for any kind of size project. So if you're a startup, if you're a large-scale company, if you're migrating pieces of code from one place to another, Bazel will definitely help you with that. It doesn't matter if you got 20 files or 20 million. If you use it correctly, it'll work. So as previously stated, let's imagine this dependency tree with each circle being a library, right? So library A depends on B and C, and B depends on D and E. Let's say we make a change in B. With the previous legacy system, everything would just get rebuilt. There was zero concept of a dependency graph. So it didn't matter if you changed stuff in the monolith or in any low-hanging frameworks, everything would get built regardless. So one line change or 20-file refactor, congratulations, you're still going to wait 60+ minutes. With Bazel, it's logical, right? It's how it should be. If you touched B, then only B and its upstream dependencies will get changed. It's so obvious and so simple. So after doing all of this and migrating all of our files for both platforms, making sure everything runs and making sure everything gets distributed and all of our stacks work correctly, all of the third-party dependencies which we use still function correctly, what do we have to show? There was essentially, I want to say a couple of days right before our first release using this infrastructure, where everyone's palms were sweating very profusely because there were no signals from internal testing that something is wrong. It was quiet, right? It was too quiet. But nonetheless, we went ahead with it. So what were the results after all? Our build time was decreased by 80% for both incremental and absolute builds, so building from scratch and doing small changes. We finally had a clear dependency graph. It was easy for other engineers to see what got built whenever they made a change. And that introduced a very new, interesting concept. Okay, if we have everything targeted in very small libraries, instead of building the whole app, can we just build like smaller apps, like slices of the app? This started off as a grassroots effort, like somebody trying to build a tiny version of the app for a specific feature, and more teams adopted this. We did not plan for this. This started as a project from our team, but we never really implemented it directly. It was adopted by other engineers, and this was awesome to see engineers teaching each other how to use this and coming up with other ideas and improving the system. And as said before, it was a large-scale change, which was completely transparent to the end user. At the end of the day, the only thing that changed was a build number from 346, whatever, to some other build number that's much larger. And that was it. We were really, really excited to hear from customer support that after 7 days of rolling out to larger and larger percentages of our users, there were 0 reports of anything. It was quiet. No one noticed, no one complained. I was like, well, okay, congratulations. When in fact, we had changed literally everything about how we built and used our app. So before we started, I'm pretty sure these numbers need updating, but the concept is the same. Both projects had a number of smaller targets. We were trying to create this already before the Bazel migration, and okay, guys, it's taking way too long to build the app. We need to start breaking it out. But obviously not at this scale. So we still relied on 2 very large monolithic targets, which were the original build targets for the app written 10 years ago, where everything went in, and a couple hundred smaller targets for iOS and Android. So, static frameworks for iOS and modules on Android. Right now, I'm pretty sure we are over 5K. We're maybe at 80, maybe 8K for iOS, and Android is maybe at 12,000 targets. So these are 12,000 individual libraries that contain a couple of source files getting linked together. Our builds are down from 60 minutes down to 10, again, depending on what you touch, but the average is around 10 to 12 minutes. It's very interesting when I talk to colleagues of mine that almost forgot what it was like a year and a half ago. So yeah, we launched last year in summer, so it's been a year and a half at this point, that are starting to complain, or like, oh my God, we have way too many targets. I forget on which dependencies. Oh, I need to create another dependency. I need to create a new target. So we're suffering from success, let's put it that way, where we have too many targets and now have to think of like, okay, let's merge these ones together, but not create a new tiny monolith. So it's really great to see this, that our problem now is that we have too many targets and that people aren't complaining about our build times anymore. It no longer takes 60 minutes to pull in a change. We've had multiple instances where we had to put in exactly 1-line changes to fix production incidents, and in about like 30 minutes, we were in and out. That was it. Luckily, it was during a release with small percentage, and we were able to push that release super fast. Previously, that would have taken us easy 3 to 4 days, something that in that nature. One final analogy. Imagine the car on the left being, your family car, mom and pop's car. It's a bit rusty, it's a bit old, but it gets the job done. You love it, you care for it. Now, applying Bazel to it basically turns it into a super awesome monster truck that can do backflips. That is what Bazel did for our project. It turned him into something we couldn't have imagined. Our initial hopes were, okay, let's just migrate everything. We don't really care about build times. Let's just make sure that it works so we get out of our old infrastructure and into the new one. We did not expect for everything to actually become so much better. But it did. So really awesome results by the end of it. And that was our story. Thank you very much for attending. I've been Timo, and I hope I've made you at least 1, 2, maybe 25% more interested in trying out Bazel. And if you have any questions, I'm more than happy to answer them.
Hi. What was the largest step of the build process that was cut down to size by using Bazel? So what took most of that?
Most of the entire migration?
Of that hour, actually.
Honestly, I think when we finalized migrating all of our smaller targets. Those were easy to do, just seeing the relationship between them and going from the bottom up. Once we hit the monolith, it became clear that we had to do some refactoring to ensure that it works as intended. So one thing that is important about Bazel is that you need to separate things into libraries based on language. So whereas with both Xcode and Gradle, you could have Objective-C mixed with Swift all together, it doesn't matter. Bazel works differently because you have specific rules for specific languages. For iOS, an example would be that we had to split our monolith in half. So basically separating the Objective-C part of it from the Swift part of it. For Android, it was slightly different, but quite similar, none the same. That was the most difficult part to migrate because it was the largest, and there were a lot of unknowns due to a lot of legacy code. That's where we had most of our runtime issues, because assets weren't loading, or they were misplaced, or they were misnamed. And we essentially just found a lot of places in our app that shouldn't have worked, that were masked by the old system. We're like, how is this thing not crashing? Oh, because Blaze uses some more explicit flags for optimizations, and now it's crashing. It should have always crashed, but if you don't check, you don't know. So I would say that was the part, along with runtime testing, because that was just a lot of rinse and repeat, creating over 200 bugs, fixing them, sending out to testing, and so on and so forth.
Thank you.
So everyone's going to use Bazel? Is that what I'm hearing? Okay, we'll check on you. We have the power. All righty, folks. Again, I've been Timo. Thanks for attending. If you have any questions about Bazel, migrating monoliths, breaking monoliths, or what it's like to work at Google, feel free to hit us up at our booth. We can talk about it.